Hello students, Mr. Rowell here again with another Computer Programming 11 project guide. Over the next 2 lessons, I'm going to be introducing you to a new project to check in about our skills that we've been learning, to give you guys a bit more of an open-ended design project, where I'm going to be laying out for you the basic setup of just one component of this next project, and then you will be completing it on your own, as well as adapting it in a more creative way at the end. What we're aiming to create here is a digital synthesizer and later on, maybe a soundscape where we can use the keyboard and or mouse to interact with the screen and produce various sounds, like a synthesizer that you may be used to using might do. In part 1, we're just going to get the basics of our project set up, and in part 2, I'm going to take you through some of the more complex logic involved before I let you work on the next parts of the project on your own. In the background here, we see what a good example of the final part of part 1 of the project might look like. It looks like a digital synthesizer piano. And here's how this works. You see there's instructions on the screen. Click Run, then use your keyboard to play. I've mapped out the keys on my keyboard to each of the keys that we see on screen here with different notes that you might expect to hear on the piano. And when I hit Run, if I reach for the A key, the very left of my keyboard, and press it, I hear a note on the keyboard being played. If I press the S key to the side of it, I hear the next note one whole tone up if you're a music student. And if I press W, the kind of the in-between key above it, I hear the in-between notes. In this case, I guess that would be C sharp. You don't need to know the names of the notes necessarily, but hopefully that you can hear the differences in sounds to map out where these different sounds would appear on the keyboard. So you'll see the whole range of notes are mapped out properly with the in-between black notes, each being triggered when they're supposed to. Also note that when I press down a key, the visual look of the key changes while the sound's being played, and then changes back like it looks in real life. We're trying to mimic real life as much as possible here. So the first part of our project is we're going to set up a single key to function in its basic functionality, and then afterwards we're going to adapt it to a bit more complexity so that you're able to actually set up this whole keyboard yourself. In our first project, we spend a bunch of time setting visual information on our screen. We're going to do so in a slightly different way in this project, using actors primarily rather than the world class, but many of the same principles do apply. So let's jump back here. The project file that I provided you with might seem a little bit bare. You'll notice that in your world class, you simply have the creation of your world. We're going to use the size of the image of the nice wood background for the piano that I provided for you, 800 by 340. And notice there's no other information in our world class. It's possible in your projects you might want to include some information here, particularly if you want to save the world, to have information about your key locations mapped out permanently. But for now, we're only going to be worrying about what's inside of our key class here. This is the information that I've provided for you. To get things up and running, we're going to need 3 things. We're going to need a constructor for our key class. So each key that's created, there's going to be information created for it. We're going to need an act command. So that means that with whatever speed is in our project, actually for this project, a high speed is just fine. It doesn't make a huge difference other than maybe there being a bit of lag on a lower speed setting. We're going to create some logic for what needs to happen as the project runs. And then we're going to access a method called play. Notice it's a public method, void, meaning it returns no information, and its information that it's receiving is empty. It's simply just going to perform an action. It's a very simple method, but it's going to be very important for actually seeing our project through. Something else you're going to notice in this project is that it comes with a lot of information. In our sounds file, we have sound information for each of the keys you might want to map out. As well in images, we have information for black key down, white key down. Hopefully you get the logic of what these are describing. This wood is our background, already been set up for you, but other information you're going to have to set up yourself. Let's go ahead and create a key. The first thing we're going to see here is that I've already created an actor. Just in case you forget, I created a subclass, I called it key, and then I selected from my file the white key image. But it already exists here. I can just see that it exists by holding down Shift when I select that class on the side, and I might just place one down right now just to see it in the world. And if I hit Run, I press A, I press different keys on my keyboard, Give me button mashing, nothing's happening. I click on it, nothing's happening. There's no interactions, which should be expected because if we pop back into our code, there's no instructions given for what should happen. Before I add any instructions, I want to talk about this term that may be new to you. It's called a Boolean. A Boolean is the same thing as saying a true or a false. If Boolean equals true, that means that for this particular name, it simply is in a state of being true. Or this name can be in a state of being false. Those are the only two options for a Boolean, true or false. And there's many uses for this that we have in programming. For now, I'm going to define it as false. One of the background pieces of information you might be curious about is if I don't actually define it here, it's going to assume that it begins in a false state. But just for clarity's sake, I am going to tell it to exist in a false state to begin with. We're going to use this down here in our act method. I need to think about my key. Now I changed some information, so it reset the world. My key needs to have some instructions about what it does each second. And in this case, we're going to think back to our very first trial project where we were moving the crabs and wombats around our screen. That each act, it's going to be waiting for some information about my input and waiting to act until it gets that information. So let's remember how we do this. We need to use this if statement, which we call a conditional. It waits for a certain condition in which to act. I'm going to throw some logic in our brackets that are going to define what happens when this condition is existing or is happening. Now in our previous projects, we put things in here like if is key down. And we're going to do this again here. I'm going to say Greenfoot.is key down. And in this case, let's just put the A key like we saw in our first example here. Notice I close my brackets and then I close my outer brackets. I made sure that the brackets are both closed here. So I'm looking for if the A key on my keyboard is down. If you forget where to get that information, remember in our API, under my Greenfoot class, I can look for the method isKeyDown. And it reminds me how the method works and the information that I need to put into it. Just a reminder to take a look at our API. You should have it open at all times. If the key down is A, then I want this to do something. What do I want it to do? Well, I want it to play the note of this key. I've already created the outline of a method. I haven't set the rules yet, but I'm just going to call this method for now. Right now, it's not going to do much. It's going to do nothing, but it still acts as it, which is a great thing. And let's just insert some information here. So when it plays, what do I need it to do? Well, if I go back into my API under my Greenfoot class, we have another method here called playSound. Play sound from a file. Let's get it to play one of the keys. So I'm going to go back under my sounds and let's choose just whatever. It doesn't really matter what note we choose right now, but let's just choose 2A as a sound that we can access. Before I move this over, it's a wave file, 2A. It needs to be spelled the same way that it is. I'll just leave this right here on the screen. I can just shuffle things over here. I'm going to tell Greenfoot to access and play a sound. What's it called? Well, I have to send a string as the name. I'm going to call this 2A.wave. I have to include the file type as well. So if the A key is down, play the wave file 2A. Let's insert our key into the world and run this. And when I press A, I get an error. File not found. Could not find 2A.wave. Did I misspell wave? I did. Okay, let's try this one more time. That was extremely loud. You'll notice that there was some weird glitchiness going on with it. I'm sorry about your ears, but I wanted to point something out, maybe not in such a nasty way. What happened was this file is being accessed a whole bunch of times at the same time because it's based off the speed. While the key A is being pressed down, every moment the project's being accessed, it's playing the sound file. Let's crank this way down, maybe not all the way down, and run this. I'll hit A, and you'll notice that the sound is much quieter because it's not being accessed as often. But we don't want our project to be bound to the speed of which it's running. Again, I apologize, that was probably really loud, but that's the way it goes sometimes on YouTube. I need to set some more logic in here to be a bit more intelligent. I don't want it to play A all the time that it's down when Act's running, especially if the speed is cranked up. I want there to be a little bit more cleverness going on in here. So I'm going to base this logic off of this idea here, is down. I want it to only play if the key is hasn't already been pressed recently. So here's what I'm going to say. I'm going to leave some space here. I'm going to put this exclamation mark. This means negative or not. I'm going to say this. Not is down. This means, in other words, if is down is false. This exclamation mark means false. So if is down, if the key is not yet down, which it shouldn't be at this point in time at the start of our project, and then I'm going to include this piece of information here, a double and symbol. This means that both these conditions need to be true for this if statement to run. If the key is not down and it detects that A is now pressed, so nothing was pressed yet, and now a key is pressed, it will play the sound file. It will only access it if it's not pressed yet. However, we've told the program that it's always false. There's nothing that would change this yet. So I need to tell it to redefine this as true. What's going on here is I'm saying, first check if the key isn't down yet, and then the key is pressed, play the sound, and then tell the program that the key is being pressed, which will mean that this cannot run again because it's actually down right now. It's not down, if that makes sense. So this won't keep on running a million times a second if the speed's cranked up really high. The problem with this, however, is that if I play this file, I've played the note. You can hear in the background maybe I'm spamming my key and it's not going to play again. That's a problem. I've set this to be true. It says it's down, and now it believes that it's down forever. I need to create a new piece of logic to reset it back to its original state. So I'm going to create another if statement. This time, I'm going to say, if my Boolean is in a true state, meaning if is down is true, and track with me here. I'm just going to get my brackets set up here properly. All right, let's take a look at this if statement. If the Boolean variable is down is true, which it would be if I had pressed the key recently, and the Greenfoot is key down A is not true. So this means if I've let go of the A key. So if this setting became true and I let go of the A key, what I want it to do, I want it to turn this Boolean back to false. What this is going to allow me to do when I reset this is every time I let go of my key, I press the A key, then I let go. Right as I let go, this runs. Sets is down back to false, meaning that this will be able to run again after I press the A key. Press it as fast as I want. The speed of the program might limit how fast you can press it if you want to play around with that. But what I've done here is I've allowed for an intelligent usage of actually interacting with this key. Now there's one thing that we can do here to make this a little bit more intelligent. I don't see any visual feedback about when the key is pressed. And in the project, I provided you some information about how this looks. This is currently set to the image of the white key, but we have another image, if we jump back over into our project file here, of white key being pressed down currently. So what I want to do is while it's being played, I want to change the image of my key to white key down.png. This is the name of the file, whitekeydown.png. Make sure all the capitals are the same. I think I did it right. We'll see if I made an error here. And so when I run this, once I press A, it goes down to the pressed look. But you'll notice it doesn't switch back. I haven't programmed that in. Here, where I switch the values back to the original state, I am going to now set the image back to my original file. Let me just double check I spelled this right. whitekey.png. So now when I let go of the key, then it's going to change the look back to the way it originally was. Let's take a look at that works. As long as I'm holding down the key, it's in that first if state. Once I let go, it's in the second if state, and then it resets back for the first to run again. All right, so it looks like here I have the functionality for my single key to work. In the next short tutorial, I'm going to show you how to add a little bit more to what we're doing in here before I set you off on your main task of creating the whole keyboard itself. See you in the next one.